Hi everyone, my name is Joshua and today I'm going to talk about crucial topic, which is network protection to the cloud. Let's start with the basic. What is cloud computing? The cloud is a network of remote servers providing computing services over the internet. It's become the backbone of many businesses, offering scalability, flexibility, and cost efficiency. Why is network protection important? The move to the cloud has introduced new challenges. Data breaches, cyber threats, and vulnerabilities are real concerns. Effective network protects is critical to safeguarding your data and operations. Let's discuss some common threats to the cloud network. Data breaches, DDoS attacks, malware, ransomware, and insider threats. Now, let's have a look at the strategies to protect the network in the cloud. So first, we're going to talk about VPC. VPC allows the resources from AWS like Amazon EC2 instances to be established, subnets to be created, routing charts and security groups to be set up and connected, and particular IP address ranges to be defined. So first, we name it as assignment to VPC, and the IPv4 CIDR block, we're using the IP address 10.0.0.0/16, and we're not using the IPv6 CIDR block. And the tenancy, we are using the default setting. Next, second, we're going to talk about subnet. It is a practical set of IP address within the VPC in a unique accessibility zone. So subnetting helps optimize IP address utilization by breaking a large network into smaller segments, each with its own range of IP addresses. This helps conserve your organization's network's public IP addresses and reduces the need to purchase additional IP addresses. So here's the setting. We name it assignment to subnet, and the availability zone is US East Ohio, and the IPv4 CIDR block, we are using the same 10.0.0.0/16. And third, we're going to talk about security group. It serves as a virtual barrier for the AWS instances, traffic that comes in and leaves. So we name it as assignment to security group, and the description is to allow access to SSH developers, and the VPC, we're using the respective VPC ID. So inbound rules for HTTP, the protocol is TCP, and port range is 80, and the source is anywhere. So the address is 0.0.0/0. And for SSH, the protocol is TCP, and the port range is 22, and the service source is anywhere. So it's the same. For the outbound rules, for the SSH, we're using the protocol TCP, and the port range is 22, and the destination is anywhere, so it's 0.0.0/0. And for HTTP, the protocol is TCP, and the port range is 80, and it's this for the destination is the same, so anywhere. And fourth, we are going to talk about route table. Route table is a set of regulations that list network packets toward their intended locations. So we name it as assignment to route table, and the VPC we made it before, so we are using the assignment to VPC in here. And yeah, that's for the route table. And the fifth is net gateway. It permits private subnets to be linked to the internet while rejecting external internet connection requests. So we name it as assignment to net gateway, and the subnet, we're using the previous subnet, assignment to subnet, and the connectivity is public, and the elastic IP allocation ID we're using AP lock. And finally, an ACL is type of network security that manages traffic based on a set of both inbound and outbound rules. We name it as assignment to an ACL, and the VPC, we made it before, so we're using it in ACL. As you can see, it's assignment to VPC. Thank you.
Hi, I'm Ingyi Wang, and I'm going to present the part of compute monitoring and security, and there are 8 sections here. And so first of all, it's AWS EC2, and this is the cloud service offering scalable computing capacity and simplifying web scale cloud computing. As you can see, the users will go through the internet gate and inside the public subnet and do the EC2 instances, and we can set like there are set different EC2 instances in here, and offering full control and rapid scaling to adjust to changing computing needs. Yeah, and then second one is auto scaling group. This is pretty good feature services in AWS for us can get the features of flexibility, time saving, and fault tolerance, also availability, scalability, and also like cost efficiency, and also pretty easy to modify it. And this one is AWS Amazon CloudWatch, and this is about the monitoring. Here all the like a message monitoring, analyzing, and also the resources management. There all the information on the signals will go through the CloudWatch and check different signals. And here's the CloudTrail also for monitoring. And also this can protect the message, not protect just monitoring and record, and it will print the log, store the log into the bucket and to the SNS. And this is the guard duty for the security, and it can protect the EC2 or like cloud AIM your bucket from some threat detection, low false positives, yeah, seamless integration with AWS services, and just protect from the unauthorized user and also malicious software. And this is how I create guard duty. I'm just enable the guard duty here and set the S3 bucket. And if you are not if it's the S3 bucket not existed, just create one. Yeah, and also remember to increase findings using the KMS key. And here's the symmetric key to encrypt and decrypt. And also configuration finding alerts using SNS here. Yeah. And this is about the WAF. WAF is to protect our VPC from like web-based attacks, anti-DDoS threats, and also regulatory compliance issues. Yeah, and this is how I create the WAF. Just go to the WAF in AWS console and create the web ACL. Yeah, here's how I create it, and just make sure all the configuration is correct. And then this is the show standard. This will automatically enabled, so we don't have to set it. And this is the like AWS service for prevent network and transport layer DDoS attacks. This is the safeguard. And this one is the AWS Certificate Manager. It's the service streamlines SSL TLS certificate management and ensuring secure data transmission. As in the picture, you can see that the clients have to go through this certificate manager, and then after that they can reach the EC2 and also the load balancer. Yeah, and this is our design architecture, and I'm going to present yeah. So this is the EC2 I created, and I create the AZA, AZB. Here is the different availability zone here. I created through the auto scaling groups, and here's the auto scaling groups, and we can see here. Yeah, the maximum is 6, and this is B. This is A here. Yeah, and we'll just create here and click the create and link and link it to the EC2, and we can create it from EC2. And also here is the CloudWatch. I create put all the monitoring like auto scaling groups monitoring here, from the AZA, AZB, and also the total EC2. So I put it here. It's more easier to monitoring all the things. And this is a CloudTrail, S3 CloudTrail, and we can get like a lot of like event history from here. Just create trail here, and then we can record and monitor all the information and get the information of the log here. And this is my presentation. Thank you.
Hello, I'm Shupti. Now I will talk about AWS storage services. AWS provides a lot of wide range of storage services. Some of the storage services which we have worked on are RDS MySQL, Amazon S3 Glacier, Amazon S3, Amazon DynamoDB. Now first I will talk about RDS MySQL. Amazon RDS for MySQL offers the benefits of a managed service with automated backups, patching and scaling, reducing administrative burdens. Its high availability, security features, and compatibility with MySQL make it an ideal choice for dependable, performance-driven database solutions. It also supports global reach with replication and read replicas for widespread application availability. These are the steps. First we have to navigate to RDS, then select Create Database, then choose MySQL Database Engine, then configure advanced settings and keep database name as it is, create automatic password and review, and then launch our database. Here are all the steps with picture. The second one is Amazon S3 Glacier, which is a cost-effective archival storage service, ideal for long-term data retention with 99.99% durability. It offers secure data encryption, scalable storage, and flexible retrieval options while meeting compliance requirements and making it a reliable choice for archiving and backup needs. So for this as well, we have to first go to AWS Management Console, then select Services, then choose Glacier. Then we have to create our vault and give it a new unique name. Then set the event notification as do not enable and then submit. Here are the pictures. Then the third one is Amazon S3, which provides scalable, durable, and highly available object storage for a wide range of data types, from documents to multimedia. It offers data security, easy access control, and seamless integration with other AWS services. With cost-effective pricing, S3 is ideal for applications, backups, and content distribution. The steps are select services, and then go to S3, then create bucket and provide it a name. We have to choose reason for this and then create. If we want to add files, then we have to upload those files. Here are all the pictures of our work. The last one is Amazon DynamoDB, which offers seamless scalability and high availability for NoSQL databases, ensuring low latency access and robust performance. Its fully managed service reduces optional overhead, while features like security, automated backups, and global replication make it an ideal choice for divers. It's a high demand application as well. Its flexible data model suits various use cases from the web and mobile apps to gaming and IoT. The steps are, after going to AWS console, we have to go to DynamoDB, and there we have to create the table and all necessary data we have to input, and then we can manage the data. So here are the steps. Apart from those, Amazon QLDB is most important in AWS because it offers a fully managed, highly secure, and immutable ledger database service, providing an unchangeable record of all transactions, making it invaluable for application requiring trust, transparency, and compliance. Then the second one is KMS, which is known as Key Management Service. which offers secure and efficient key management, enabling encryption, access control, and data protection across various AWS services. The last one is AWS Artifact, which is important as it provides critical compliance, security, and auditing resources to help AWS customers meet regulatory requirements and ensure the security of their cloud environments. Thank you. That's all from me.
Hello everyone, I'm Inu Wang. Today I want to talk about identity and access management in Amazon Web Service while ensuring the security of new financial service in the cloud environment. IAM is crucial to controlling and securing access to AWS resources, and I've been actively involved in those processes. And I make them like 5 parts: users, roles, policy, user group, and multi-factor authentication. First, for the users. A user is an individual or application entity that interacts with AWS service and accesses the AWS platform. So first, creating IAM user was a key step in this journey. IAM user represent the individual or applications interacting with AWS service. To do this, I went through the following steps. I decided to provide user access to the AWS Management Console, so set up a custom password, assign those users to specified groups, granting them full permissions without additional restrictions. Finally, I will check the settings and create the users. And the second part, roles. Create roles was equally important as a role provides temporary access permissions. So a role is an AWS IAM entity that provides permissions for temporary access. It's a key part of security best practice and is not associated with a specific IAM user or entity. I accessed the IAM interface and clicked on Roles under Access Management and click Create Role, select AWS account as a trusted entity type, and enter the account ID, ensuring the multi-factor authentication was required, and add the necessary permissions, filling in the name and description, and then create a role. The third part is policy. Policies in the form of JSON document define what actions are allowed or denied for users, groups, or roles. Custom policies were essential for us, and AWS provides some built-in policies, but also allow you to create policies based on your own needs. I selected policies and click Create Policy, check the appropriate permissions, click the actions, and then use the Attach option in the drop-down menu. Select the entity that needs to be linked and attach the policy. And next part is user group. A user group is a logical collection of IAM users that simplify rights management. A policy can be attached to user group to make it easier for their member to inherit permissions. A user group made our rights management more efficient. So we attach policy to those groups to ensure that member gets the right permissions. And I select a user group and click Create Group, enter the group name, select the specific user and attach them to the group, and create a group. The last part is MFA, multi-factor authentications. And to add on an extra layer of security, we implement multi-factor authentications for some users. And MFA is an additional security layer that improves security by requiring users to provide multiple authentication factors when they are logging in. And I assess the user interface to select users who need MFA, and choose the MFA device, and installing the required application and scanning the QR code to set up MFA. Actually, you can choose another options, but in here I choose to use the applications. And in all of those steps, my goal was to ensure the security of our cloud environment for new financial service by following those IAM procedures and to the cloud security life cycle process. We can protect our resources and data.